It doesn't really do much.
All right.
Sitting. Alright.
All right. Hey, real quick.
There we go. Mr. Ward, my calculator seems to be broken.
Anderson. Yes. Sit. I don't want to hear about it.
I thought we were friends.
You thought wrong.
Do you think teachers can be friends with students?
No.
Do you think
Alright,
teachers can
so-
be friends with me after I graduate? I think it's a friend is something you spend time with.
Girls, go sit.
I can see him staring.
Mr. Ward,
So I
when are
think
the other teachers coming in to watch you?
Tomorrow.
Tomorrow.
Okay.
Should
There's
I-
gonna be quite a few. I think I'm expecting 5 or 6.
I bet you guys are doing that too.
this
In
is
this class? So we have to
Let's
shut
make them all
up.
sit in the front. Let's all sit in the back and we all
Okay.
show off how we normally do.
All right.
What chapter is this?
Chapter 4. Okay. All right. Section we're in.
Sitting.
Okay, the section we're in. We're in 3.1. We're doing calculating the derivative.
Yeah, you did. I can do that.
So now the big thing today. We have a couple new topics I want to cover. I want to do sum and difference formula today. I don't believe. I think we may have discussed this like at the very end of class yesterday. I want to do a quick example of this with our shortcut because we do have the shortcut. It's called the power rule. I want to cover that today. Hey, let's knock it up. I don't want to have to stop you guys talking like over and over and over today.
That's
You have no idea.
Nicole, go to school.
Not on me. Like in my car.
It just seemed like something.
Okay, let's go. Let's take a seat. All right. So power rule. I want to go through the shortcut today. Talk about, instead of doing the limit formula of it, the limit formula, how we can just do the shortcut where we do the power rule where you drop it. We're going to do a couple examples of like the most extreme cases of the power rule today, where you can kind of see how it's used in different light, where they're not always the simple, easy problem that I give you. How I could change it, and you have to like manipulate the problem before you can start. So we're going to look at a bunch of examples of those. After we're through those examples today, we're going to try to get some hands-on where you actually get some time to like try this out, share some results with me on the board, and then after we're done with that, we're going to try to tie this all together and talk about how do we graph. Because we haven't come back to this yet. We ended on chapter 2 with graphing. Graph,
Wait,
the
we
first
don't have
graph.
the graph this chapter though.
Yes, you have the graph in this chapter.
Yes.
So, okay. So we're going to get back to graphing because we're going to go to second derivatives and talk about how do we know
We
what
already did
second
second
derivative is.
derivative.
We're going to have to graph it.
like a party that needs
Ooh.
But won't those
We
be,
don't even know how to graph the first one.
That's what we're going to go over.
won't those be
I'm
easy
sorry,
to graph
don't get
because
mad
they
at
don't
me.
have
And your
it?
test would say otherwise, that you know how to graph.
Whoa!
Oh,
He just called you out!
I did really good on that test, so.
Not the graphing part though.
Okay. All right.
No, I got, I
No, she did good on graphing.
On the back graph,
Why'd
not
you
on the front
On
one.
the front one, you didn't draw any in the arrows.
So, all right, let's do something different. Here we go.
Might be just it,
Some
okay.
and different. Can
I think I'm gonna leave school.
All right, here's the idea.
I'm lying it.
You just called them up from
She did really hard.
Okay, let's say that this is my function. Now I know there's a P and Q in there. These are just supposed to be represent something that you're adding together. I don't really care what P and Q are. They can be any, any variable in there. I'll make up one here in a minute. When you want to take the first derivative, now the first derivative can be written in a bunch of different ways. It could be f of x, f prime of x. It could be y prime. It could be written as d dx, like find the derivative with respect to x. That's how it's pronounced. Of this function, whatever it is, p and q. All right. So here's how it works. When you want to take the derivative of something that's being added together, the trick is you take the derivative of the first thing. So you're going to find whatever, f prime of x is, it's just the derivative of the first thing added to the derivative of the second thing with respect to x. So it's like whatever p is, it's p prime. So you're going to do the whole power rule where you drop it out and you do the normal rule. So here's the idea. Let me give you an example. Because I know, like, if you didn't see an example, that gets confusing when you see p's and q's. So let's say it was, let's say it's 5x to the fourth plus 9x to the third
Wait, do you have to write those other three
Minus-
things down?
plus 1. What?
Do you have to write those down?
Well, this is just talking about how you do it if you're adding things together. So if this is like the generic formula that they say in the book. If you just want to write down the example, you'll be fine. All right, so now, the idea is that, do you agree that all those things are being added?
Yeah.
So it's a sum rule. So they're being all added together. So the rule is, if I want to find the first derivative, and we kind of did some of this stuff yesterday, you would just drop the power out front, and we're going to do it for each term individually. What will separate these is the plus signs. So I'm going to have to find 3 individual derivatives, and once we have that, then we can go to our final answer. So for instance, we drop the power out front, and you multiply it, so this is 4 times 5,
20x.
and then you subtract 1 off the power.
Mr. Ward, how does
Oh, I thought you put 45 and I was so
7x
confused on how
It's,
you got that.
it's looking at, if you do enough of those limit formulas, like where you're doing the limit, like the actual limit,
Yeah.
like the full thing, you'll start to notice that every answer, every single one, was always, the power was 1 less, if you did it every single time, so they started noticing the power was always 1 less, and they started noticing that whatever was in the power was affecting the number in front of it every single time, because it was dropping down.
So how do they
27.
do a proof for that?
Doing the proof of that is actually showing the limit formula, and then factoring out of each term, like taking each term separately and looking at how the power was affecting the actual derivative itself. So like it was actually doing a ton of factoring.
Was it a difficult proof?
No, it's just one of those things like to look at it,
How
you
long
just
has
have
that
to.
concept been around?
Long time.
Like,
It was, this power rule was created with Isaac Newton, when he was first doing derivatives for the first time. And then the notation we use, like these primes.
That was Einstein.
That was Einstein, that he used that type of notation. We just stuck with it because it's super easy to look at. It's just quick, it's quick notation. We don't have to write ddx and all these limits.
Did you take like a math history
So,
class?
wait,
or-
I have
just-
an actual question real quick.
Yeah.
So a first derivative, or a derivative, is the slope at one exact point.
Yes,
What would the second one be?
it's looking at the acceleration of that slope. So like as you go down a ramp, it speeds up. And then as you go uphill, it slows down a little bit.
At that one
Is
particular point?
Yeah, so like it's looking at that point, like is my slope like, is it increasing or decreasing, and at what rate is it changing? So we'll look at that. When we actually get the graphs, it'll make a lot more sense. Because right now, like, see, here in first derivative and second derivative, you know how to calculate it. But until you actually see the purpose of it, then, it's kinda
Yeah, not,
Okay.
Physics.
yeah.
What did you take
Okay.
a math like history class? Or?
What's a crystal?
Did you actually?
Yeah.
Did you like it?
Yeah, that's one of my.
It sounds like a chemical class.
It was. Alright, now, next. My last one, I dropped the power up front, so I'm gonna take 1 times 0, and you're gonna have to subtract 1 off the power. Now, this is where it gets a little goofy. It was a 0 for an x in the back. When you drop the 0 out front and you subtract, this thing just turns out to be 0 anyways. Anytime you take a derivative of a constant, it just turns out to be 0. Because the power on the variable was 0 and you're dropping that out front, so 0 times anything is still 0. So my shortcut to you is like anytime you're taking a derivative of a constant, just put 0 in that spot. You don't need to like go through that process of what I just did. Okay, what's 4 times 5?
19.
20.
20.
What, do you actually want us to write to it, or do we have?
X to the third, yep.
27.
It's really easy.
Yeah, try to write this problem down. This is a good one to have. No joke, like you want this problem written down somewhere. That way we can kind of see like how the power rule is working when you're adding a bunch of things together.
You'll figure it out.
Does
We
it
have
work
to-
if you subtract
We have to
them?
note
There
that
is a
it's
subtraction rule, we'll look at subtraction. It works
Is it
on
the same
subtraction.
way?
Same exact format. You just have a bunch of negatives in there.
Are you?
Wait, do we have to write 0, or can we just leave it out?
Eventually you can just leave it out. Like I know it will disappear. I always write 0 as good practice, and then I just add it in later.
You subtract-
All right, so that's what you're looking at there is the first derivative using the power rule on when you're adding things together. You just find the individual derivatives one at a time. And you just add the results together. Because the reason why this actually works. So just to answer your question earlier, you asked like the proof of like why did they come up with that? Like how do they know you can do it for each one?
Yes.
Is because it goes back to the limit. That when you calculate a limit, you can separate it over things that are being added together. So you can just take individual limits of everything, which would be individual
That
derivatives.
sounds like logarithms.
Yeah, same thing. It's the same
How long
general
have those been
concept.
around?
Long time, way longer.
Longer than
derivatives.
really?
Yeah.
Longer than that?
Yeah.
Did the ancient Greeks use them?
No, but they probably used the concept behind it, how to solve for x.
Who
Because they can.
invented the logarithm?
I don't know.
Sir
That's something I don't know. I don't know where that came from.
Isaac logarithm.
So, all right.
Isaac Newton.
Maybe Leonard Euler. I think it might have been
Who is
Leonard
that?
Euler.
Never heard of it.
Did a lot of stuff with differentiation and stuff, so.
What
and
time did you
precalculation,
say?
so. 1600s.
Why have I never heard?
It's kind of
Not
big.
important.
But what's
Yeah.
that the new one, 1600s?
Okay.
No, he's way prior than that, wasn't he? New one's prior.
Well, yeah.
Yeah.
Okay, all right. So, sum and difference, power rule, limits, okay, difference. Let's talk about if they subtract. Now, Sid brought this up. Wouldn't that just be the same rule if you're subtracting? It's very, very similar. Let's just go with the same first two. I'll just do something like this. Okay, I'm just gonna go with the first two. If you subtract, the only difference is you're gonna be subtracting in the middle, so the negative sign has to stay there. I think of it as an actual negative number. So the negative sign will stay, and you do the same power rule that you just did a little bit ago. Even though it's the same rule, because I can change this problem to be an addition problem. I can make it plus a -8, and it would just work over the same rule. So 4 times 5, x, 4 minus 1, 3 times 8, and then 3 minus 1, okay? And you do all the work here, the final answer, we get 20x to the third, you're gonna be subtracting 24x
I
squared.
thought it was supposed to be the same as the other problem.
It is the same, I said I was gonna just change it a little bit, so. All right, questions, comments about that? Okay,
I love this.
all right. Just to check whether you're on the same page as me. Okay, I'm gonna give you a piece of paper right now. You're gonna put your name on it. This is not a quiz or anything like that. It's just a self-check. It's a self-check. Where are you at right now? So you get the right
So
answer.
multiplication and division are the,
Individual.
are the exact same.
Yeah, it's the same concept because you can make that problem an addition problem by using negative numbers. So.
Thank you, Mr.
I'm
Ward.
picking up what you laid down.
This your word, I need opportunity.
Right 5 pointer on top, okay? That's what it is.
Mr. Ryan, I'm ecstatic for the opportunity.
You tell that's my name?
Do I just make up the problem? That's a random problem.
You tell that's my name?
Say it out loud.
Yeah. No, that looks like a P.
Hey, let's start cursing here.
Bradshaw. It says
Well, I figured
Bradshaw.
so, but
See, you knew.
because it was your paper, it's
Okay, let me try on recent.
There might be two.
You already know.
Okay,
This one.
all right. Name on it. Name on it. Again, this is not a quiz or anything like that. I just want to see where we're sitting right now with this stuff. Are you comfortable? Can you do it on your own? How fast can you do it?
Very comfortable.
Okay, here we go.
how fast, is that what you just said?
Yeah.
And not as fast as you are.
Yours at 5? Yeah.
You guys can have
Is that your word?
You can go faster.
I don't like it there.
Is your word loaded?
Why?
Hour.
We're gonna have like 15 people there. We might have 20.
More, I believe we get the gym.
Using an
How about we
abacus.
play each other for
Abacus.
Is that?
Why?
You're like,
They're all like a foot taller.
you slide like.
No, we
Let's slide
4
over.
and 5.
How about we have a layup? Left-handed layup.
Okay.
Really still wanna try that again?
Okay. Hey, problems on the board. Without talking to your neighbors, I'd like you to find the first derivative. Use your shortcut method. That's the power.
Done.
Okay.
Is that,
Okay. When you're done,
what's
just
that
hold on to it. Hold on to it. Put it down beside you. Okay.
But it's just more.
I beat you all.
Is it this?
That's.
No.
That's all.
Oh, I did it wrong.
Mr. Ward, is that right?
Thank you, Mr. Ward, for letting me realize my mistake.
Mr. Ward.
Yeah, I did.
Oh my god, I got it.
Mr. Ward, who's your name?
Yours.
I forgot to do it.
That's right.
I see stuff. Is this correct?
Derivative of the constant is.
1415 minus 2.
Wait, did you say yes or no?
He said probably you.
Say no to me?
That's yeah.
Oh. I think it's
Mr. Ward, if you had to shoot 18 left-handed layups in a row, how many would you make?
I didn't do any steps. You know yet? No.
7989.
I want to see mine. You didn't put it in there.
35.
Yeah.
32.
Yesterday.
Wait, he's like,
Yeah, I want to see.
no, he shoots basketball right-handed.
Didn't you have to take yours?
Yeah.
He does everything right-handed.
32.
Write this down.
14,
I tried to take
Oh, yeah, because he broke his hand, that's why I
Nope,
asked.
you're taking it
Mr.
now.
Dog was 5-pointer.
89.79.
I went to my comfort zone yesterday and I bought a blue sweater.
You know how many digits that
Like
is?
that color blue, like a sweater sweater.
What's the date? I'm sorry.
Like a sweater.
That squiggle in the back really threw me off there.
Yeah, like a.
That's what I thought I saw. I was like, what do you have in the bag? And that's why I had to double check it real quick.
Is it?
I said, alright, okay,
It's like patterned.
Hey.
You know,
This thing
it's
recently.
20.
okay, here's what you need to make sure of.
Cool.
Okay?
Oh, this was good to be okay.
Here's what you need to make sure of. Drop the power up front. This was a simple mistake I saw right away, but people made fixes. Forgot the 4. Gotta drop the 4 out front. I saw a couple people had to fix that. The 5 times 2. You drop the power out front. Subtract. And then the 2 becomes a 0 and you don't need it. Anytime you take a derivative of a constant, it turns out to be 0. Okay, next to the problem. If you got it right, star it. If you didn't put a slash through it, it's just a quick check.
Mr. Cotto would not approve us grading their own 5 points.
This is kind of the extra.
It's an integrity.
And then you drop that out front.
I forgot how to make a star. Make a star. Make a star. I can't
Your
make a
name?
star.
And 0 times n equals 0. You don't need 0. You can just leave it off.
Mr. Cotton, one minute.
There's the same. Is that what you were asking?
I
Okay.
feel like
I forgot how to do
Sorry,
it.
I thought you meant like, why is it 0?
No.
Oh, okay.
Let me see it.
No, I
Yeah,
didn't.
so it didn't matter if it was plus or minus, it's the same thing.
Let's try to.
Okay, alright. Next one. Next one. Number 2.
I forgot. I don't know how to make a star.
Okay, next one.
Is it?
I'm not.
I stole this from Hanson. He said, that one's blue.
Okay, now, here's what I want. Okay, now you know the general rule. I want the second derivative.
Are those X's or T's?
Oh, Mr.
Oh,
Wall,
this
that's
one?
not cool.
How would you do that?
I don't know what I just did.
I
Okay,
think you
thanks,
made them.
sorry.
me just do it.
Okay, second derivative now.
Don't we just do the same thing?
Yep,
So-
twice.
Oh, man,
Oh.
Mr. Ward, you're getting tricky.
Oh, wait,
Second
I did that
derivative.
wrong.
Okay, this one you might need to write down the first line and then go to the second line after you get done with that.
You
Okay?
think so?
In theory, if I was doing this, I would have 2 lines of
Keep
work.
looking at the wrong one.
Right here.
Oh, I got the same answer.
Right here.
Okay.
Right here.
Are you proud of me?
Is it this?
Reese got it wrong. Shut up.
Got it
I
right.
can read it.
Yes.
Justin, what are we doing?
Why'd you take my music with me?
Mr. Warren.
Wait, is this what you got?
Hey,
Yeah, look at
at
that.
What did I do?
Okay, you did that.
Okay, is this a 1 up here?
6'5".
Wanna come check my work, Mr. Ward?
3.
Yeah, it is.
Yeah, 6'5", 3'5",
What's your
8'9",
name?
Yeah,
8'7".
because when you go down to 0, it makes it to nothing.
I knew that you just got rid of that.
8'9", 7'9".
Are you doing?
Because when you take,
Yes,
when you
we
go
have it
down, because
memorized,
you have to
like
take out
20
front
digits.
times
No,
by
it's
now.
20 digits.
3.141592.
And that turns into a 0.
I actually know.
Miss.
We what?
You feel?
3, 5, 8.
I was trying to do it.
Exactly.
We did it in 2s, and then I was trying to do it in
3, 2,
1.
3, 8, 4, 6.
Mr. Ward, you say you're nervous or this is good?
You're at 6.
Oh, 5'9".
I could tell, I could see what you said.
How long?
Ray could tell, look, if you were to like 100.
Go.
Ray could tell, brother. There's an app that you can get.
It's a
game.
1, and then you subtract it to make it a 0. And then it gets rid of the X again, and you still have a
That's
6.
so cool.
Okay,
It's so
do we have,
pointless.
I think, Mario, you're still working, right?
I just wanted to do that by the end of the year. but
That's
I
what we
got-
said. Oh my
I got
gosh.
stopped after like the first week of school. Justin, hey Justin, we said that last year.
Okay,
Yeah, and then last year I stopped again.
we good? You need a little more time?
The mitochondria is the powerhouse of the cell.
Okay. Alright, so, you can put a star or slash through it, no matter what. Alright, first step.
No matter what.
I'm not slashing.
Okay, hey, hold on, we'll get to it here in a second. You have to find the first derivative first. So that is where you drop the power up front, subtract 1 off the power. Drop the power out front, which would be 6x, subtract 1 off the power. Drop the power out front,
There's no. That's true.
subtract 1 off the power. And then anytime you have constants, it's just zeros or minus zeros, wherever you want it to back. That's the first derivative. Now the weird part is this part right here. I actually wrote that wrong. You have to subtract 1 off the power. You're going to get an x to the 0 back there. And the idea is that x to the 0, when you actually subtract 1 off the power, that x to the 0 will just go away. And so what you're actually left with is you're left with, before I go on to the second derivative here, you're left with 3x squared minus 6x plus 8. Because 8 times 1 is 8, and then x to the 0 is a 1. So that's what you get for first derivative. Now, most people got there. Then you have to go one more step for second derivative and do the same rule. And you drop the powers out front, so that's 6x, you just subtract 1 off the power. Drop the power out front, 6 times 1, and you chop the power off, so it'd be x to the 0, which would be gone, and the 8 turns out to be 0. This is your answer. Because the power goes out front, and you subtract 1 off the x. Okay, now, the simple fact that you guys can calculate that right now.
The sixth derivative is 0.
Okay. Sixth derivative, you'd be undefined by that point.
Yeah, no, 4 is 0.
Okay.
The fourth derivative.
3.
Third one would be 6, and the next one would be undefined after that. All right.
Mr. Ward, say I have the numbers 18, 32, and 12, and you assign a random amount of x's
What
to
is the
each
69th
one.
derivative?
What do you think about that?
I'm indifferent.
You don't like that? I think you should.
All right. Now, hey,
69th derivative is 0.
hey, star that problem if you got it right. Slash it out if you didn't. It's fine. This is a self check. Where are you at right now? Okay. Next one.
My third.
Third one. This is my last and final one. I want to see kind of what we can do with
But I'm
this.
writing them all. But I'm adding 2 every time.
What? Or this is fun.
He was like,
Yeah, can I use my calculator?
I feel like he's funny.
Are we just doing the first one of this?
First derivative.
That's actually hilarious. Like you
With the x we just want.
Okay. Hey, find the first derivative.
I don't like this. 2/3 times 4.
So, first derivative.
Come check my
Oh, that's
half
fine.
minus 1.
That's 1/2. That's 6. 6x.
I don't really have room on my paper.
We subtract 1, so it's just half.
Yeah.
It is, right?
Minus
You're
2.5.
not giving it back to me?
I know what to do for this x.
You don't have
Minus 0.5. Can you do that?
Can you have a
Can an
negative?
exponent be negative?
This guy needs
Oh,
to
it's a
put on the
fraction.
bottom.
It's a fraction. I
That's
think.
what I did.
Huh?
Yeah.
You lost.
So what do
You
you
did
want
put this whole
over?
thing on the bottom?
So it's minus 2.5 what?
Mr. Ward, do you want to see how good I am
Well,
at making
1/2
back
of
is
0.5.
Because it's
Like the
3
negative
halves,
0.5,
not
like
5.
Yeah, so it'd be like negative
3
0.5.
halves, so
Technically wrong.
So
1 over 0.5.
You're right, I did
What I did
it times.
Or is it 2.5 over x to the...
Let's do 2, I think it's 2. Second.
Negative power.
fraction over fraction.
The bottom of the whole thing.
Fraction.
Yeah. It's called a chain.
You
Because
can
it's called a chain
move
reaction.
that whole thing.
Stop
So
doing
it's
that.
Can I do 5? Minus 5.
Yeah.
X is second.
Mr. Ward,
squared.
I don't
Like it's x and then
JP, look at this
X squared.
rainbow.
It should be a half, negative, it should be a half.
Mr. Ward, what's your favorite element?
What are you saying?
It should be
Would you say it's plutonium?
Any
negative
diamond.
1/2, so
What
then it's
weight?
6.
Is this right? 69
1/2
carats.
is 1 over 2.5.
69 carats.
Oh, yeah, that's kind of fun.
I have. Mr. Ward,
Oh,
How big is that?
I don't like that.
I give up.
Okay, hey, so kind of this one really threw people off. Okay, wait, what am I checking on?
66,
69 carats? That would be a lot.
almost.
Yeah.
Are you missing a variable? Is this right?
Oh my goodness, they have a lot
Do
of
I need an
work.
X here? I mean,
Is this one right?
It's, I don't know what to do with the last variable. I don't know what to do with
What's your name?
Why is it 2.5 on the bottom?
because it had a negative power, so you had to put
I do explain.
1 minus,
2.5 didn't have a negative.
Well, I think we're almost out of here.
what do you mean?
It will end up, when you take 1 off of a half, it's negative 0.5.
Alright,
1
We don't know
hey,
what to do.
this class was very split on this problem. I made it on purpose to see, oh, sorry, Darcy.
What?
I made it on purpose to make sure that I could see where did people get their answers. So here's the idea. You had to drop this out front. Most people did not get that wrong. When you're taking 4 times 3 halves, you basically take 8 times the top divided by the bottom, right? And you had to subtract 1 off the power. That's the part you have to kind of calculate. Now, on the next one, you're taking 5 times the half, you're dropping the half out front, and then you're taking and you're subtracting 1 off the power. A lot of people just got rid of the variable. You don't get rid of the variable, you subtract 1 off of it. It's a common mistake, a lot of people make that. Okay, now, 4 times 3 is 12. 4 times 3 is 12, divided by 2 you get 6. And when you actually have to subtract these, you have to get common denominators.
0.5 share.
So 2 over 2, and this turns out to be x to the half power. Because when you subtract fractions, you just subtract the top number, so it's 1 over 2. Over here, 5 times half, that's 2.5. You can leave it 5 halves. Take 5 times the top. You can leave it 5 halves.
That's bad.
Now, when you subtract this, you're going to get a negative half. That's the part a lot of people forget or they don't you realize you can do. Okay, now that you're there, this x can move. It has a negative power. Just the x moves. So, what do you have?
The 2.5 over x to the half.
Good.
Okay, Justin.
Now, you did not have to have that. If you stopped here, you're fine.
No.
If the book says you can't have negative exponents, you'd have to move that around. And now, what does the power of half actually mean?
Square root.
Means square roots. So, here's what you're actually doing. The final answer, if you want to go without any exponents that are fractions, here it is.
But I don't know like anything.
Minus.
Or maybe 2.
2.5 over square root of x?
And here's the worst part.
But then you have to tax it by the square
Yeah.
root of x on the
You
bottom.
wouldn't-
This is just too much.
You wouldn't leave the radical on the bottom.
So
You'd
you
have
gotta
to
do
get
the
rid
times
of
and
it.
stuff.
It's the whole process.
You never
You gotta
stop
talk
doing
about
the problem.
Alright, that's why I wanted to see how far you'd get and how far you'd actually go. It's kind of a trick question. Kind of made it up, so let's see
I
what you do.
multiplied by 2/3 instead of 3/2. And then
Yeah, I
it's
saw.
like,
That's what I saw.
you're like, yeah, that's not right. I'm dyslexic.
Okay. Hey, these are good things you guys are trying to figure out. The simple fact that you guys are doing this level of math at this stage is what you learn an entire semester in calculus. Like, no joke. They spent an entire semester teaching you how to find first derivatives with limits.
So is it okay that I left it in a negative exponent?
If I was doing a test, I want to see that.
Good, that's what I.
That's what I want to see. Now, if I ever, in homework though, we might have sections where they say you can't leave any powers that are negative or fractions. So then we have to start changing. Okay, do we feel comfortable in this stuff? So
I feel so good about this.
Alright, I need your name on there. If you did not feel comfortable with a certain problem, put a star next to it.
Wait,
You said
put
when
a
it's dark, you got it right.
If you get it right, put a star next to it. But if there's a certain problem that you don't
Circle
like,
it, circle it.
circle it.
Just over and over and
Can
over.
I pick them up?
No,
Mr. Moore, I
yeah.
already started after you
Name's
told me
on
I had a problem.
I just want to see where you're at right now.
Look, so there's a star and I had a problem.
There you go.
Turn that in for me.
Oh, give us 5
Okay.
points.
Alright, now, hey, just warn you guys, they're getting picked up. We have teachers in here tomorrow. They're just in here to watch the election.
What teacher?
The lecture tomorrow. Election, no.
What election? Mr. Ward, I elect you as vice
No.
president.
Okay.
I elect myself president.
You don't get these if you don't accept the role.
Just go.
Okay, I'll take these with me.
Hey,
Now you don't have any.
there's 6, I don't even know them yet.
From where though?
You've never met him?
They're from around the building. They're coming in here to watch.
Around the building?
Yeah, they're in our
Someone's gonna be like.
I need those back. They're background teaching, they want to see what we're
No,
doing.
it's like.
Can I show you?
So-
Justin, can I try it?
Yeah,
Okay.
here, like.
While the random teachers
No,
who don't
hey.
teach math come into our class.
Oh.
Expand your mind.
Okay,
Yeah.
now, hey, real quick here, what I want to talk about is the graphing idea, what we're going into, and the shortcuts that we're going to talk about, because there's one way to graph is the way we did it on the test, where you actually plot where those graphs are going, okay? What we're going to be talking about next is the purpose of what first derivative and second derivatives are, and that's why graphing is actually really important to actually look at the graph itself. So here's the idea. Okay, here's the last bit of notes I'd like you to write down. We're gonna go into this more tomorrow. Tomorrow will be we're gonna be going hands-on, we'll be moving around the room a little bit tomorrow, because of the activity we're doing tomorrow.
Mr. Ward, have you ever met the teachers that are coming? Well, a little bit ago you said you didn't.
I don't know which ones it is, they're picked
They're supposed
randomly.
to
So,
Do they know which ones it is?
yes, they got an email, I didn't
No, they
receive
have
the email.
Wait, why this class though?
Because he's a model /teacher.
The model.
It was Newburger a couple weeks ago. They went in their room.
Really?
Stephens is a new
It
one.
was afternoon. So, alright, okay, alright, real quick.
All the caskets really shuts it down.
Alright, here's the idea. If you had a graph, The first derivative would be the slope at any particular moment. We talked about that before. Like if I wanted to find the slope at this spot right here, maybe that's the number 3, the slope would be 0 there. So, the first derivative, at this number, at 3. Hey, I just told you to shut up. Shut up, seriously. So, first derivative at 3, it would be 0. Be 0. Why that's important is because when we were graphing in pre-calc, when we were graphing at the beginning of the year, and on that first problem, yes, we've done that first problem in this class, on that last test we took, we did that in 3 different units for us. First chapter we did it, second chapter we did it, that was on your test. We did it in pre-calc, you have it, it was like the 3rd chapter of pre-calc, you had to graph things, polynomials. This is the part that we were talking about, how do you find the peaks and valleys on a function? You actually have to find the first derivative, because the first derivative would be 0, and then you could factor it apart. So, the first derivative at this location is 0, and the idea is that if you know that this would be 0, let's say you didn't even know what the function was. Like, they gave you some crazy formula, you find the first derivative, you set it equal to 0, and you can factor this thing apart, because there is a bunch of spots on this graph where your first derivative is 0. Because whatever the first derivative is, you can factor it apart, and these answers would be the x numbers where it would actually hit 0, which is actually really clever. So maybe that's 3, maybe this is half, like, so it'd be like x minus 3, this would be x minus 0.5, and maybe this spot is 2. So x plus 2. So now that you know that those are the x locations, you can go find what the y value is at that current moment. Because all you have to do is pick one of these. Pick one of these. So I'm going to pick 3. And you simply take the 3 and you plug it into the function. So, because I know that's one of the peaks and valleys. So if you take the function, the normal formula, and you were to plug 3 in here, it would spit out a y number, and that's where the valley hits.
0.
0 in our case. Now, that's not the first derivative, it's just what the value is. If I plugged in 0.5 here, 0.5, it would be this y number where I hit. That's why we actually find first derivatives. It's not only just to find the actual slope on a graph, but it's to actually find where those peaks and valleys are if you had to graph something. That's one extra thing we can throw in now on that first problem on that last test. That's something we're going to be looking at, like down the road. That if you had to graph a polynomial, 3rd root, 4th root, okay, this one goes 1, 2, 3, so it's a 4th root type of problem. If that's a 4th root, we can take the first derivative and then actually factor the spots that are left and see where those peaks and valleys are and actually calculate them. Because it requires you can factor, it requires you can find first derivatives with my shortcuts because it makes it a lot easier. So that's why we actually have it. That's the overall question. People always ask, like, why do we do first derivatives? To find slope. Okay, why? What's slope good for? Right there. It's used for peaks and valleys. So like, I always try to tie it back to like always doing like if you're in a business degree and you're trying to read off, like you're looking at a graph of all the sales margins. And you want to figure out when was the highest sales value, like when was that? Or what was the value right there? And you just had a graph in front of you. You could actually come up with the equation that would fit the mold, because that's what we do in pre-calc and calc. We can actually come up with equations. So we find first derivatives, plug in all those zeros, factor it out, plug in the numbers into the function, you can figure out where those peaks and valleys are. So it's data analysis. That's number one thing people use it for. You get one of the hardest classes in college, no joke. The hardest classes in college that you go through is business calculus. Holy gods, it's hard. Like I took a bunch of calc. I took a bunch of calc in college because that's just my major. I was math. Their math that they were doing in a business calc course was way harder than what anything I had to do, which is like silly. You're like, I was like a math major, and you're like, why didn't you take that class? Because they're learning how to apply that thing that they learned in calc to something that's useful in a business class.
So what
right?
you're telling us is you learn how to do it just not useful ways.
Yeah, like that's no joke. Like no joke. My professors like they tried their best to like every once in a while throw a story problem in like this where we use it, right? And they explain like this is why we have it. But like their course, that's all they did. Every single problem, like and it was not easy. Like the stuff they're doing is like
you take that? That
super
sounds like something
over
you
the
would
top.
You should go
I
back.
probably would like that, but wasn't going into business. I wasn't going to try to start a business. I didn't want to go into that analysis part of it.
You should start a
So,
business.
no.
You could
No.
sell pie charts.
No, stop. Question.
What business are you going to start?
No, stop. I'm not doing that. All right. Now, okay, first derivative. We use it for that. Now, second derivative, if you didn't have a graph and you had just a function, maybe this is the function of your sales number for the month. This one right here, the one problem we did earlier. What a second derivative tells you is whether I'm increasing or decreasing for my slope, so are my sales rising or running, but what a second derivative tells me is how far it's actually changing, like how fast it's changing, the acceleration of it. What we were talking about, and I was talking to Drosky about this,
Yeah, you were.
this is a decreasing function right in this moment. Like I'm losing profits. But as you get to this point right here, it is starting to speed up like faster. I know like up here, it's like starting to slow, and then it starts to speed up really quick. And to right here, you get to this point where it's changing direction, so it slows down again, because it's hitting the bottom right here. It starts to slow down until it gets right past the point of tipping, then it starts to speed up again. That whole speed up and slow down process of like going uphill, downhill, up, down, right? That idea is that's what a second derivative tells you. It tells you, okay, how fast is my rate of change changing? Like how fast is it going? Because if you know the speed, you know if you're going uphill or downhill. Because, oh, hey, my acceleration for this business model is saying that I'm increasing. You know, the speed is increasing. I did the second derivative or this formula we have. It's increasing. You're probably losing profits there. It doesn't happen where you're going to start speeding up with making profits. If you're speeding up, it's probably because you're losing money. So you need to look at that. You need to look at the numbers, and that's what we're going to be calculating. Like it's fine and dandy to find a first derivative. It's great to find a second derivative. But what we need to do is figure out what is that telling me. And that's the part that a lot of people struggle with on the last test, right? That we're getting to that part where we're graphing, right? We're taking a first derivative, graph it. Take this function, graph it, and look at all the parts. That's tough. I understand it's tough. But we have to figure it out. Now we have to add more to it. So we have to start to review. Now tomorrow, I already warned you of this. We're going to be doing similar stuff we did today. We're going to be doing a couple examples on papers like we did today to kind of see where you're at. Books tomorrow, yes, you'll need a textbook.
Book, notebook.
Book, notebook. Okay.
Calculator?
No. Yeah. Well, yeah, maybe.
Can I see my test?
Yes.
Can I too?
Yes.
You ready?
Okay. Well, that's it. Okay. All right. We're done for the day. So be ready to go tomorrow. Gotta be on your best behavior tomorrow.
Friday or